Hello everyone, so today we are going to do Leetcode daily challenge. Hmm, So it is simply shortest path in binary matrix. So let me show you the question for the same. Okay, now comes the part that what our question is about, what are its constraints. So let's first focus on the constraints. So basically our constraints are like that it is a small matrix of 100 and it is a matrix, so it is n cross m, so n rows are there and n columns are there. Wanted to confirm, yeah, it is n cross n, so same number of columns and same number of rows are there. And then state of ij is either 1 or 0 because it is a binary matrix. So values and rows and columns now are done. Now comes the next part, that what this question want us to do. So it simply wants us to find a clear path. And what does clear path means is it is having 0, 0. Basically, this is index means at a particular index of the matrix, that is 0, 0 coordinates. So it is required to reach this n minus 1, n minus 1 coordinate position, and that process it is required to have only 0, 0 as the values. Means if there is 1, then it is either a blockage or something, so it can't move from that path. And in the second example, we can see that the path is directly from 0. It could have gone here, but it would be somehow a longest path for it. Means not longest, but longer path. So that's why it took this one and then this. Because 8 directions are also allowed. If 8 directions were not allowed, only 4 directions were allowed, then this particular would have been the path. But as 8 directions are allowed, so this is the path. Now comes the next part, that how we are required to do this question. Okay, so before doing this question, let me walk you through some things. Like in the matrix, as we are required to find the shortest path, right? So for finding out the shortest path, we are always required to be determined by BFS rather than DFS. Due to due to the BFS nature of not giving in depth directly, rather than checking for its neighbors and moving towards the destination. So the thing is that in BFS, we are simply required to go towards its neighbors in its 8 direction or 4 directions, whatsoever direction which is required there. But in DFS, it is not that case. It is simply required if it is going in right direction, then it will go the right direction until it reaches the end, this border, means this particular border. But in BFS, that is not the case. In BFS, it will check for all of its 4 directions, and whichsoever direction it finds, like here, if it goes up, then there is nothing to go. If it goes towards left, there is nothing to go. If it goes towards down, then there is 1. And if it goes towards the right, then there is 0. So the only option it is having is for this particular 0, not even going towards the down. So that's why in BFS it will be going towards this right direction for first. This could be done in DFS also, right? But now comes the next part, which will directly show the difference, that's why we are using BFS. So now comes the next part, that it can also go towards down direction also in this BFS, but 1 is there, so it won't go. But in DFS it won't be going in down direction. It will be only going towards the right direction if it is choosing the path to go towards the right direction for time being, right? So it will go towards this right direction. But now comes the part that it is required to choose towards the diagonal, right? because it can go in a direction. But if it would have been doing DFS, then it would be going in this right direction only. It won't have chosen this diagonal direction for time being. But in DFS, it is allowed to choose all eight direction at a particular node. So that's why it has chosen this particular diagonal direction. And now it is able to determine the shortest path rather than going towards its right. So that's why while going here and then going here. Now here comes the part that because of being chosen through the BFS, it is able to go in all eight direction and easily able to find out that it can reach the destination in shortest possible time. So also a few more key points which are required for coding this question is that as per the question we are required to traverse in all eight directions, so we would be accordingly making our direction vector for the same. We could have done it directly also, but the thing is, like explicitly making some direction vector would make our readability of code much better, and even in those system design downs and so on, and even in coding for industrial level, means industrial level coding also. If the code is more modular, it is much more simpler to read. So in that context, we could use a direction vector for this thing for increasing modularity of the code. Now the next part is need to keep check on boundaries. Yeah, as per this question, we are required to check for the boundaries. As if we are going out of the bound of the matrix, then so earlier code won't work and it will give us runtime errors. Then we need to check if it is 1 or 0. So if it is 0, then need to proceed that if this particular 0, then only we can choose this, else we won't choose this. If this is 0, then we'll choose this, else we won't choose this, because when it was 1, so we were not choosing. So this is the direction of this point. This is the explanation for this particular point. Now comes next last part, that is make visited by changing 0 to 1. So because BFS is a thing that if we are on particular node, then we can also go in that direction also. So for avoiding that thing, what we are required to do is we are required to mark the previous node as visited. So that's what I have written here, to mark it as from 0 to 1 so that we don't visit that node again. So these were the key points which were required here. Now comes the next thing, the time complexity and space complexity in which we would be coding this. See, whatsoever solution we are required to propose, we would be simply traversing this whole matrix, right? We are not required to store anything extra. Everything would be in this matrix itself. So in that sense, we won't be using any other extra space rather than using this for 8 direction thing. But that is also somehow constant because it just uses till 8. So presently the time complexity would be for doing this BFS in this matrix would be n into n only. And the space complexity, as we won't be using any extra space, we would be modifying this original matrix itself only. So in that context, space complexity would be order of 1 only. Let me once walk you through the code, then we can decide about this once more time. Presently, by the explanation, we can say that it is something like this only. I'll cross-refer once again. Now, let me walk you through the code that what then only we'll decide for the final time complexity and space complexity. Now, here comes the part. Let me zoom it. My feet won't be visible also. Okay. So, these are the pointers that clear part simply means that through 0. And presently, I just don't want to bother about space and time complexity. Let's go through this. So, the thing is, this is that direction vectors which I was saying for 8 directions, means when 0 is there and then 1 is there, so it simply represents the up direction, so on, things like that. So first, this is for checking that if it is a valid point or not. Basically, for this, it simply check for the edge cases, that if it has reached here or there, something like that. If it reaches any of this direction, then it is not valid, right? So in that context, if x is greater than equal to 0 and x is less than equal to n, then only it is valid. Because if x is less than 0, right, if our coordinate is something here, then it is not valid. Or if our coordinate is something here, then also it is not valid. So in that context, we have bounded x value, and also same goes for the y value. So this is for checking the validation of our point. Now comes the main part, that here we are taking the n and m. Basically, n is here the rows, number of rows, and m is here the number of columns. So for that context, I have taken here. Now comes the first part, that if grid of 0, 0, 0, basically the first one only, means this coordinate, if it is equals to 1, or if this is equals to 1, right? Means if source and destination themselves are 1, then we are required to return -1, because if our source and destination are themselves 1, then how we can traverse in the matrix? And even if we traverse, then there is no clear path. So in that context, this is the same. Now this is the most essential part for doing BFS. If we do BFS on tree, or if we do BFS on matrix, if we do BFS on graph, Q is must thing to be taken. So here we are taking this Q, and this Q data type is vector of int. Why vector of int? Because we would be storing x coordinate and y coordinate in it, right? So for that reason, I've taken vector of int. We could have also taken pair of int comment, that would also work here. And for storing our current node, basically processing our current node, so in that sense, I've taken this vector into current. Now for kickstarting our BFS, as simply pushing the 0, 0 into the queue, and then grid of 0, 0 equals to 1. This is for making it as visited, because I had already told that we are required to make it visited so that it don't visit that node again. So this is all for kickstarting our BFS. Now this is the whole BFS part. Now if our queue is not empty, basically this is the must text we are required to keep. And then if it is not, if this grid in M, here M is basically for this, so that's why else N would also suffice for the same. Now comes the part that if it hasn't reached the destination, because this is the destination only, right? So if both of the keys are there, then our while loop would run. So now this is the part that if we are taking this current and then popping it out, so that we are making space for, not just space, because it is not considering about space, but about the processing part. That if our node is now taken out from the queue, now we are required to process it, and we are not required to keep it in the queue much longer now. So that's why we are popping it out. Now comes the next part, for checking in all A directions. So for checking in all A directions, earlier we were having this current, our present coordinates, right? Now here we are having the new coordinates. So for these new coordinates, what we are doing is, we are simply adding the x direction I and y direction I to our x and y, and this loop will run so that it could check for all 8 directions. Now while getting this x and y, first we are required to check that if x, y, and m basically are these valid point or not, and also this grid of x, y is also equals to 0. If it is not equals to 0, then it is not the part of clear path. So again, that particular xy won't be pushed into the queue, but if it is, then it will be. And also if it is a valid point, then also only at that point it will be being pushed into this particular queue. So now, after checking that it is valid also and it is 0 also, then we are required to go to our grid x, y. Then what we are required to do, that we are simply required to go to these coordinates which are being there. Whatever value we would be having at that point, surely it would be that 0 only, right? then we'll simply add 1 to it, right? So after having that, we'll simply add that particular 1 to it, and then we'll simply have this here. So this will also let us to know about this fact that whenever we push that 1 there, so at that particular moment we are also able to get to know about that how many means how many iterations were required. Basically, like here when we were going here, so 1 and 2, so that's why 2 was our output, right? So here 1, 2, 3 and 4, so that's why 4 was our output. So in that context, we are simply filling up our present xy with whatsoever was previous, because it was starting, so yeah, it would be 0 and there, and we are required to mark 1 here. But the thing was that earlier only we had marked this position as 1. So here it would be 1 and this 1. So making it both 1 plus 1, 2. So here the answer would be 2. Like this only, doing like this, and now we would be pushing this xy, so that now xy could be processed and all at a direction. So while we would be doing like this again and again, so we will reach, means here 1 would be there, right? Means from this, then here 2 would be there because of this, then here 3 would be there because of this, and here 4 would be there because of this only. So at the end, if there is some value in this rather than just 0, then it would be returned as minus 1 would be returned. So this is the thing which we are doing in this whole coding portion. Now comes the part about space complexity. So the thing is that we are not using any extra space here, means not any extra matrix here. We are directly consuming the original input matrix, changing its own values only, and then directly returning them. So in that context, according to me, there is no space complexity for, means there is no extra space being required. It is the original matrix itself. But another thing which is there, which we missed, that was for this particular queue, because this queue is also storing and we are doing BFS here. So that's why when we are storing all the nodes into this queue, at max there could be a case when all the nodes are being in this queue itself. So in that context, our space complexity would be n into m. So in that sense, our space complexity is n into m. It was not because of the matrix, but it was because of this queue. Yeah. So this is the thing here. So this was all for this particular question. So finally, we now know that our time complexity is basically n into n. Here n into n because it is symmetric matrix, I could say directly. Our space complexity n into n again, because we are storing all this in a queue where node as mass could reach till this point. So this was all for this particular question. If you have any doubt, you could directly comment. So this was all. Thank you.